We were just talking about vectors and scalars and how they interact, and we said vector v, which is AB, whatever this is. If we have some k, k is a scalar from some field. Generally, everything you're going to be dealing with for this class is this field, F-I-E-L-D. A field is like real numbers, complex numbers. They have certain number of properties that have to deal with groups and units, and it's really nice. When you get to real algebra, which is complex algebra, or modern algebra it's called, you will find out more about what is a field. In this case, this is going to be real numbers. As soon as you go into physics, you'll find that the scalars that you're going to be using are complex numbers. But as I said, if we have k times this vector, k is bigger than 1, it's going to stretch it out. If it's smaller than 1, it's going to shrink it. If it's negative, it's going to turn it back on its backside. So let me see, what did I need to tell you? So if you have this, what is the norm of kv as opposed to the norm of just v? Remember that the norm of v is, in this case, it would be a squared plus b squared square root. This norm is the same as the absolute value of k times the norm of v, which in this case, if k is greater than 0, in this case it will be k times the square root of a squared plus b squared. And the reason why that is because k times v is really the same as ka times kb. The norm of this is the norm of this, and this will be ka squared plus kb squared square root. This is k squared times a squared plus b squared. This is the square root of k squared times the square root of a squared plus b squared. By definition, we're in real numbers in particular, by definition the square root of k squared is the absolute value of k times a squared plus b squared. And I'm so excited because I like this so much, my board work has got a little sloppy, and I'll slow down. Mellow. Okay. Some more stuff about vectors that you definitely want to know. These things behave so well. Oh, so much of physics is here. This is the beginning of real physics. Okay, so if you have vectors, let's see, let's let u be a and b, and v equal, c and d. Then vectors add like this, compartmentally. It's this part and this part. This is a plus c and b plus d. Pretty simple. Minus, I'll do it, what the heck. This is a minus c, b minus d. Let's see, what am I supposed to tell you? I'll tell you something really weird too that nobody ever gets, especially the first time. So remember, there's vectors and there's scalars. There's a difference. 0 is a scalar, the number 0. But there is a 0 vector as well, and they're different. 0 the scalar and 0 the vector are different. Now, when it comes to multiplying by them or doing whatever, the same thing kind of happens. But the 0 vector is the vector that has no length. It's like if you talk about circles with certain radii, there is the circle that's just a point. It's called a degenerate circle, which I kind of like, the whole degenerate thing. Degenerate circle, it's just a point. Nobody says that 0 vector is the degenerate vector, but it's weird. I remember the first time I couldn't separate them out of my mind because they don't really behave differently, the scalar 0 and the vector 0, but this is a vector. Here's who it's going to matter to. When those of you who go to linear algebra, this will end up being a big deal because it will help. What is the definition of a vector space? It has to have one of these. right? And a subspace. But I mean, it may be a year or two before you hit linear algebra. You will love linear algebra. It's beautiful. Okay, so another very important thing about vectors is a norm. In vectors, you want something that has length 1, so you can multiply it by things. So let's say that you have, and once again, I'll just make something up. Let's do this. 1, 2. So we'll do this right here. So this is the vector v. We have this. This is given by the coordinates 2 and 2. Okay, so this is a vector of length. Well, what's the length? The norm of this vector is the square root of 2 squared plus 2 squared. This is the square root of 8. This is the square root of 2 times 4, which is the square root. Actually, I'll confuse somebody if I do this. Let me change this. This is the square root of 4 times 2, which is the square root of 4 times the square root of 2. This is 2 times the square root of 2. I was just going to immediately say this is 2 times the square root of 2 because I'm used to thinking of the square root of 8 that way. Some of you aren't. So the norm of this vector is 2 times the square root of 2, which is, of course, just the length right here. I need a unit vector. And what a unit vector is a unit vector is a vector that has the same direction but length 1. Right? So how can I figure out what the unit vector is? And this is what you do. The unit vector, and I'm trying to remember if there's a notation. And there is and there isn't. I'll explain in a second. The unit vector is the vector v divided by its norm. And let me prove to you that this is going to be a unit. And what I mean by that is, let me prove to you it has the same direction and its norm. The norm of this is 1. Actually, this will be fun. I bet there's people out there who don't like math who really wish I would go on faster. Let's prove that this is true. There's a couple of ways I can prove it. I'll show you the slick way. Well, maybe I'll show you both ways. It's cool. So this is a unit vector. What does that mean? I'm saying that the norm of this is 1. Well, let's take the norm of the unit vector. So we're taking the norm of the unit vector. However, this is a number. So this is some number, which we're just going to pull out. We can do that. Remember, the numbers come in and out of the norm, the scalars. But then that will leave this left. And I guess I should have a little arrow over this. And assuming that this is not equal to 0, the 0 vector, this is 1, right? So that's a pretty slick proof. Okay, so my professors, who never thought I was clever anyway, wouldn't agree with me. Let's do this one, and let's see that this works, because they're going to want to make you do one of these. So first off, we figured out that the norm of this was 2 times the square root of 2. So this v divided by its norm will be 1 divided by this 2 times the square root of 2. What do we got? 2 and 2, right? However, this is a scalar. It multiplies in sign. So this is going to be 2 over 2 square root of 2, 2 over square root of 2, square root of 2. 2's cancel. This is 1 over the square root of 2. This is 1 over the square root of 2. So what's the norm of this? The norm of this is 1 over the square root of 2 squared plus 1 over the square root of 2 squared square root. This is the same as 1/2 plus 1/2 square root. And on a good day, the square root of 1 is 1. On a bad day, the square root of 1 isn't 1. My producer tells me we have a minute left. What can I say about this in a minute? Oh, so what's going on with the unit vector? Oh, first, is it in the same direction? Well, what is the direction of this vector? Well, this is the x component, this is the y. The direction or the angle will be given by the arctangent of y divided by x, which is 1. The arctangent of 1 is pi over 4, right? the direction of this is going to be the arctangent of 1 over the square root of 2 divided by 1 over the square root of 2, which is also 1. This is pi over 4. My producer's gritting his teeth. I'll be right back.